All right, stat students. So we are going to go to part 2 of our confidence intervals lesson. We left off yesterday after about 30 minutes of instruction, and we're going to pick up right where we left off. Let's go ahead and get into it. All right, so this is where we left off yesterday, and we were talking about the basics of a confidence interval. We did a question in our problem set, which I guess is still not on Kiddom, but I'll make sure that I get that up there for y'all to, if you need to print it off. I have started working on getting everything into Delta Math, so that's going to be up there very soon. I'll probably work on that after I get through today's lesson. Okay. So we talked about the basics, how to create the margin of error, point estimate. We talked about all of that. Let me get my notes pulled up. So we had these basics of a confidence interval. The big idea of a confidence interval is that it's giving us an interval of plausible values for a parameter. It's helping us estimate. We watched that video with the Bobby Bones Show, Lunchbox, guessing those weights of the callers. That's sort of the idea of what we're doing. We're trying to guess weights of, well, anything that we want. So we looked at the mystery mean example, and you had to create your value of plausible means. But that method was not technically a confidence interval, okay? So we did this question here. We wrote down these bullet points. I'm going to make a new slide here, and we're going to, I would say, draw a new line in your notes for me. And we're going to title this section, we go to a new slide here, calculating a confidence interval. So calculating. We're going to be working on today. We are going to, we'll be done with the lesson as soon as I successfully create a proper confidence interval, and we're going to be doing that for mystery means. But we've got a couple things that we want to write down. So we'll take our time with this. I'm going to pause, and I'm going to have you start by just writing this right here. So it says calculating a confidence interval, and we have this formula here. I'm going to actually draw on this, and you can add this to yours as well. We would call this the margin. Let me actually do this. Hold on. Let me erase here. Draw on this. So we would call this the margin of error. So that's a new term for us right there. Okay. So go ahead and write that down in your notes. I'll pause it, give you guys a second to get that copy done. Then we're going to put some bullet points here that we're going to have to refer to as we are trying to create our interval. So you can always create a confidence interval when you take your statistic plus or minus what's called a critical value times the standard deviation of the statistic. Okay? Now you're also going to, I'd like you to add this to the side here, you're also going to see this as what's called standard error. And I think that in the formula sheet, some of you, like especially if I'm thinking AP students, you will see this called standard error. Okay, so I'm going to pause and let you guys write what you need to from here. Let me move my camera down. So I'm going to pause and let y'all write that. Okay, so you've hopefully had time to write that. I do want to pull up some formula sheets just to mention. I called it standard error. So this is the AP formula sheet. You'll see they call it this standard error of a statistic. We're just going to say that that's a synonym for standard deviation. Okay, just keep that in mind. For dual credit students, we see this word standard error right here. Let me zoom in on that. This was from last chapter, by the way, but we're actually going to be using this formula for this unit. But yeah, you see the word standard error. It's just synonymous with standard deviation. Okay, there's not really another one we're going to be using. We're going to be talking about these formulas. These are quite complex. We're going to talk about this symbol here today with you guys, and we'll talk about what E stands for on this formula sheet. So if you have your formula sheet printed, I will be referring to this as we go through it. Also, any formula sheet or this formula sheet here for AP as well. let's continue with the slideshow, and we're going to write down the bullet points one at a time here. So you should already have this down. Let's write down the first bullet point. The margin of error is, and instead of is the, you could put equals, right? This is a super important formula right here. Knowing this is so important, and you're going to hear me talk about this pretty much all the time in this unit, okay? What is the margin of error? Well, it is the critical value times the standard deviation of statistic, or we call it the standard error, okay? So you'll write that. Next, we have this idea of confidence level. In the problems we did, we said, okay, there's a 90% confidence interval, and then we had one that was 95% confidence. So we got to talk about these confidence levels at some point, and that is about to happen soon. But it says the user chooses the confidence level, and the margin of error follows from this choice. So confidence level is going to affect margin of error is basically what this is saying. And we have a lot of bullet points, more than this here, that we're going to have to write down eventually. So it says, next bullet point, the critical value. Okay, critical value here depends on the confidence level. Okay, so when we choose the confidence level, it affects the critical value. All right, so the critical value depends on the confidence level and the sampling distribution of the statistic. All right. Next, greater confidence requires a larger critical value. And then last here, the standard deviations of the statistic depends on the sample size n. Well, that's from last chapter where we said the sample size, if we increased it, what did it do to standard deviation? Well, it made it smaller. If we decrease it, it makes it wider, right? So that's one of the ideas here, okay? So I will pause the video again just to make sure that you've got all this. Also, I need to move my camera out of the way here. There we go. Okay, I will pause just to make sure you get all these properties. There's a lot more that we have to write down about this, and I know you've done a lot of writings already, but we want to make sure that we have this information available, okay, for when we're working through problems, or we have to recall information looking at the problem set on Delta Math, okay? So have this in your notes. All right, next, let's go back to this. Let's go back to our sheet. Okay, so what I'm going to ask you to do is draw a new line in your notes, and we're going to draw calculating a confidence interval for mystery mean. We're going to go back to that mystery mean context, right? The one that we had on the first slide, right here. So this one here, where we were able to figure out what the true mean was, which now I can't even remember what it was. Is it in here? Yeah, it was 322. M is 322. So our true mystery mean was 322. Let's actually add that in here. So M equals 322. So we had to estimate what our boundary was going to be, what we were going to get for that, okay? Let's go ahead and figure out how to properly create a confidence interval for this mystery mean. Well, we have our formula, the confidence interval, and I'm going to start abbreviating things quite frequently in here. But if you need to rewind and rewatch what I call them, go back and do that. So confidence interval is equal to, it says statistic, which on that slide, this is actually, it says the statistic is the point estimate. The next time I write point estimate, it's going to be PE, okay? Plus or minus the critical value times the standard error. So I'm going to really start abbreviating a lot of this, okay? And obviously I didn't put plus or minus in here because I'm going to have to draw it because I don't think there's an easy symbol, so plus or minus. All right, so we are going to create a proper confidence interval for this mystery mean. Now, what is our point estimate? Well, we already know that from this first slide. We said point estimate. Well, 312.65, so it was this number here that was our point estimate. So I'm going to go back over here, and we're going to start by saying point estimate, which was 312.65. Back up here, yeah, 312.65. That's our point estimate. Okay, we need to do plus or minus the critical value times the standard error of the statistic. Okay, well, we don't even know what a critical value is. So we need to write a little bit about what critical values are and how they work. So let's pause on writing this for a second. Give yourself about 8 lines of space in your notes. If that means you need to start a new page, do that. But I'm going to draw another line. Okay. And we are going to write this: critical values. We're going to talk about critical values. Bold that, make it larger. All right, so this is the name of this section in your notes. So critical values, as this PowerPoint described, the critical value depends on the confidence level and the sampling distribution of the statistic. Well, so we're talking about critical value depends on the confidence level. That's what we're going to focus on right now. And the user chooses the confidence level. We actually get to pick our confidence level before we create our critical value. So this is actually something we get to choose. So first off, let's create 2 columns. We're going to do confidence level. Okay. I'm going to right over here. I'm going to say critical value. So and I spelled confidence wrong. I was so confident in spelling it that I messed it up. Okay. And I'm going to draw an arrow here because the confidence level directly affects our critical value. So you're going to add this arrow as well. And we have 3 major confidence levels that we're going to be using if we're doing it by hand. For AP students, I'm going to make a separate video for you guys for Play Pause It to help you because you can use different confidence levels by hand, but dual credit students and AP, of course, this is how this is going to work. So we have we're going to start with 3 main types of confidence levels. We have 68%, okay? We have 95%, and then we have 99.7%. And this should ring a few bells for you, okay? When you see these numbers, you should be thinking about a normal distribution, okay? Because we've talked about normal distributions last chapter, and in the fall they came up, right? Where the 68, 95, and 99.7% represented the number of deviations from the mean. What percent of data is within a certain amount of deviations. All of that is going to relate directly to these critical values, okay? So we said 68%, so we're going to draw some arrows here. 68%, and it's just like a normal distribution. 68%, how many deviations is that? Well, that is 1. So we're actually going to say our critical value is 1, right? For 95%, the critical value is 2. And for 99.3%, the critical value is 3. So that's really nice how that works out, right? It's very simple, 1, 2, 3. Another way to think about critical values is this: number of deviations from the mean. Okay? So for AP students, for dual credit students, we don't really have to go beyond this by hand, but for dual credit or AP students, if I gave you a 90% confidence interval, we're having to figure out, well, how many deviations from the mean is that, right? And that's going to play a role in this, and we're going to have a separate video explaining how to do that, okay? Now, we're going to use this information up here on this problem, okay? But let's write down some symbols, okay? So symbols. There are brand new symbols that we're going to be using. Now, for dual credit, your symbols look quite more complicated than AP. Okay? Quite a bit more complicated. Here are the symbols that you have for dual credit. You have Z sub, so it's a subscript, so it's lower, right? This is alpha, like the little fish, right? Over 2. This is one of the symbols. Or we're going to have T alpha over 2. And that looks terrible, so let me fix that. Actually, yeah. See, T sub alpha over 2. Okay. You will recognize that this was in the formula sheet here, and you're probably freaking out like, what is this number? What is this, right? And you can see they're all right there in this formula sheet, okay? You have them there, all right? So these are the three situations. We're going to have to break these down soon, but and we'll talk about those. AP, let's see, do you have your symbol on here? Doesn't look like it. You just get this. This is all you get for confidence intervals is this formula here. Just making sure. Yes. Okay. So when we talk about critical values for you guys, I can actually type this. It's not something so strange looking. You have Z star or T star. So these are your symbols. I would like both classes to write both, please. It is likely that some of the assignments I give may have some crossover. Let's talk about this. You should not be intimidated by these symbols because right now, all you need to know them as is 1, 2, or 3, okay? So I'm going to go up here. I'm going to write this out. We'll write it out like a dual credit student. So plus or minus, we're going to say D sub alpha. Actually, we won't give it a symbol just yet, but when you see these symbols, you notice. We're just going to give it a value. Okay, well, how do I pick which one to use? So we go back over here to our notes, and it says the user chooses the confidence level. Okay, so what kind of confidence level do we want? Do we want 68, 95, or 99.7? Well, we're actually going to create all of them. Okay, we're going to create all of these. So we're going to see what they all look like. So our critical value will be either 1, 2, or 3, okay? Next, we are going to, so we'll leave this as critical value. All right, minus critical value. So we'll leave it like that, and we'll add a value in there soon, okay? Now, what's the standard error? Well, standard error of a statistic for dual credit, that's what this is showing here. Okay, so you actually get a lot of good help on this. We have 3 situations here. There's one where you either know sigma or you don't, which would be means, and then you have proportions. So if I'm looking at this, this is what we would call, remember last chapter we had p-hats and then we had x-bars. So you can see the difference between those. This one says sigma known or sigma unknown, okay? So, do we know what sigma is for our mystery mean? That's our question right now. So let's go back to our mystery mean here. Ah, yes, we did know sigma, which I drew it really strangely. Let me try to redraw that. Sigma is 20. So sigma is known. So we are going to be using, AP, you'll be doing the same thing. We're going to be using this formula right here. That's our standard error for AP, since you actually have this. Where do you have this? Means. That's random variables. It's right here. Right here, yes. You kind of already have this. This is your parameters for one population. You have this formula. So we're using this. This is our standard error. This is of a sample statistic. This is standard error for a population distribution, okay? So anyway, I'm going to cut to the chase on this. This is for dual credit, standard error, okay? We're using this formula, so let's go back over here. We're going to write in sigma over square root of n, right? That's what we get. So we're going to do this for the 68%. You can write this below. I said give yourself eight spaces. Somehow mine got mashed. I don't know what happened. But we're going to do these different percents. These are the different confidence levels. Okay. There are different confidence levels, so I'm going to put that. Okay. So now for each one of these, we are going to create a new interval. Okay, so we're going to do 3. So for the confidence interval, we're going to do 3, 1, 2.65 plus or minus What would be the the critical value for a confidence level of 68%? Well, that would be 1. All right, and then what is our standard error going to be? It's going to be the same for all of these. We need sigma over square root n. Sigma over square root n, that's 20 over square root of 16. Square root of 16 is 4, so this is actually 5. So we're going to get a 5 for all of these. Okay? The standard error will always be 5. So then we do it again. 312.65 plus or minus. Now, this time, the only thing that changes is that critical value, right? Okay. Then, last one, we do 312.65. Oh, my camera's in the way. Sorry, hold on. I'll move that. All right, there we go. Plus or minus 3 times 5. So we have 3 different confidence intervals that get created here from this. And to create our confidence interval, we're going to use a lower and upper boundary for each one of these. Okay. So we're going to grab the calculator. We're going to take, let me make a new document. Hold on, I can just make a scratch. I can just use a scratch pad. Let me do this here. So I need to do 312.65. We're going to add 1 times 5 is 5, so add 5. Then we're going to go back and we're going to subtract 5. All right, so that gives me 307.65 and 317.65. So 307.65, 317, and I have to erase a little bit. Let me actually erase these so that I can what I need. 0.17.65. Okay, we do the same thing now, except it's going to be 2 times. So we'll start with the lower boundary, 2 times 5. So that's lower boundary there. Upper boundary. So we get 302.65 and 322. So 302.65. 322.65. All right, next we're gonna do 3. So our margin of error is 3 times 5 this time, so that's 15. So we go here, we'll go upper boundary, and we'll do lower boundary. So 297.65 and 327. So 297.65. And 3, right? 327.65. Okay. So what we have done here is we have created successfully confidence intervals. Now, ones of these capture the true mystery mean. So remember that M is equal to 322, right? So you'll notice that, and you can add this on yours, you'll notice that this one does not capture it, right? This one does. But that also should make sense, and we got to talk about this confidence level a little bit more. That should make sense because we were more confident in the others. If I go back to the example where I said, okay, I'm going to guess the weight of a student. I did this in class and they were not impressed. I said, you're going to weigh between 0 and 300 pounds. And they were extremely unimpressed by that. And I was 100% confident. I knew that it was going to work. Okay, I knew that I was going to get it correct. So that's sort of the idea with this 99.7% confidence interval. This method should work 99.7% of the time is what that's saying. Does it help us narrow it down? Not really. Okay, because there's still, it could be any value. It doesn't necessarily tell us what that true parameter is, but it gives us, we should be confident that it should work 99.7% of the time. It should be in there. 95%, it also captured it just barely. It just barely captured it, but it actually did. Okay, 95% of the intervals would. This one, 68%. You don't typically see 68% used in real life. Most of the time, most real life situations are going to use 95% confidence intervals. That's very typical because you do want to capture the true mean, okay? So this middle one is our best interval here. This is like the best guess that we could make, but obviously both of these capture it, okay? So today we learned how to successfully create a confidence interval. So let me pull up the problem set. Okay, so this is number 29 for AP. For dual credit, this is going to be number 25 on your problem set. And this one is a 95% confidence interval. Some of the others on here are 99%. There's different values on there. So we're just going to do the ones that have the 68, 95, or 99.7% calculations, okay? So really all this wants is the point estimate plus or minus the margin of error. And really all we need to do is find the margin of error to answer this one. So we know it's going to be 7 plus or minus margin of error. I do want to talk about this with dual credit. E, this is how they list it, E, right? Point estimate plus or minus E. That's what they call, E is margin of error, all right? That's what they have there. By the way, also AP, this is number 29, okay? So let me pull up formula sheet real quick, and this, we're going to end the video after this, by the way. But this is what they have to create your confidence interval. E is the margin of error, okay? E is the margin of error. That's how they list that on there. And it gives us these symbols. Now, we're going to read this scenario and work this problem. It says, an SRS of 100 postal employees found that the average time these employees had worked for the Postal Service was X bar equals 7 years. So that's sample mean equals 7 years. So that's the mean of the 100 postal employees with a sample standard deviation of 2 years. Assume the distribution of time for the population of employees Postal Service is approximately normal. That's important. A 95% confidence interval for the mean time mu of the population of Postal Service employees is spent with the Postal Service is. Okay, so really we just need the standard error. We know the point estimate 7, so we need critical value. We have E equals critical value times standard error. Okay. So what is the critical value if it's 95%? Well, that's going to be 2, right? So we say 2. Standard error. Well, how do I find standard error for this? We go to our formula sheet. We have 2 options. You have sigma's known or sigma is unknown. So do we know what the population standard deviation is? Well, if we look at the question, it tells us this. This is the standard deviation, but it's not sigma, it's S, which is sample standard deviation. Normally we see it as S sub X, right? S sub X is sample standard deviation. In this chapter, we're gonna be seeing it just written as S, okay? So we're gonna be using that formula instead of the other. Now, AP, since your formula sheet does not tell you this, let's see, I think actually you get it on this next page. No, it's right here. You actually get this here, yeah. Standard error for a sample statistic. So you have this formula here. So that's what they're using on this formula sheet here. So we need S divided by square root N. That back up. So we want the standard deviation of 2 over square root N, which is, this is N, right? 100. So that's 2 times 2 over 10. That equals 4 over 10. Which equals, I think that's 0.2. If we can get a calculator, 4 divided by 10. Oh, it's 0.4. Duh, I should know that. What am I doing? 0.4. 0.4 is the error. That's our margin of error. That's what we just found. And you'll notice that sometimes questions will ask you to either, like we put ours in interval notation. Obviously this one is D and it wants it in this formation right here, this format, plus or minus. Oftentimes though, for my questions, you'll be putting them in lower boundary to upper boundary. So the lower boundary would be 6.6. Upper boundary would be 7.4. We are 95% confident that this interval is actually going to capture the true mean, mu, true mean of this. We're trying to capture this right here, right, mu. All right, so that's an example of what a test question will look like right there. We're gonna have tons and tons of practice moving forward through the next couple of weeks, but we at least have a starting point. And I'm gonna go ahead and stop the video here. We've got 30 minutes in today. If you have any questions, let me know.